On the left, OpenAI targets a $1 trillion valuation, and Anthropic nears $100 billion. Investors are betting these companies control a rare resource, frontier-level AI. But on the right, that walled garden model is beginning to fracture. High-end AI is becoming a downloadable, aggressively cheap utility. The catalyst for this shift is GLM 5.2. As shown in this feature breakdown, GLM 5.2 is a massive 744 billion parameter artificial intelligence system released by a Chinese AI lab, and it is available for developers to download under an open MIT license. We are watching two global strategies collide in this AI paradigm matrix. On the left, the U.S. approach locks its highest performing models behind premium subscriptions to maximize margins. On the right, the Chinese strategy prioritizes open weight diffusion, releasing core architecture to capture global market share. If open, downloadable models become the default infrastructure for global developers, the core logic supporting those trillion-dollar American valuations collapses. Investors are paying for scarcity, but the market is rapidly producing abundance. To handle complex enterprise work, an AI system needs to hold massive amounts of information in its active memory. This diagram illustrates GLM 5.2's 1 million token context capability. Instead of processing a single page of text, the model can ingest an entire corporate code base, terminal logs, and system manuals all at once. This benchmark plots win rates in complex software engineering. Notice the cluster. GLM 5.2 scores 74%, placing it directly between American models GPT 5.5 and Claude Opus 4.8. The takeaway is simple. GLM 5.2 only needs to get close enough that corporate buyers stop paying a premium. The economic gap between these models is massive, as demonstrated by these side-by-side cost gauges. Anthropic charges $10 per million input tokens and $50 per million output tokens. GLM 5.2's API drops those same metrics to $1.44 and $7.40. That is an 85% cost reduction for nearly identical engineering capabilities. Enterprises are exploiting this massive price gap through a process called intelligent model routing. As shown in this flow diagram, a company splits millions of AI requests into lanes. High-risk tasks still go to premium closed models, but the vast majority of computational volume flows straight into cheaper open models. This routing hollows out revenue for premium providers. AI computation stops being a luxury good and becomes an interchangeable, low-cost utility. The speed at which these open models have caught up has triggered severe geopolitical tension, centering on a practice called model distillation. Distillation is a machine learning technique where a smaller, weaker student model is trained by analyzing the outputs generated by a much more advanced teacher model. American labs argue their models are being strip-mined. This infographic shows automated queries fired through a locked US API, funneled into a data factory, and used to train cheaper models. However, the note box clarifies an important point. Public sources do not establish that GLM 5.2 itself was built using unauthorized distillation. Still, the broader reality remains. If the outputs of multi-billion-dollar American models can be systematically harvested to train cheap open-source competitors, the defensive walls protecting the U.S. tech sector are permanently compromised. The financial danger becomes clear when we look at how these companies are built. This stacked visual represents the valuation structure of a U.S. AI lab. Everything at the top, the brand, enterprise trust, safety infrastructure, and distribution, rests entirely on the bottom layer, model quality scarcity. As open competitors crack that foundational layer, the entire multi-billion-dollar structure above it begins to destabilize. Ironically, U.S. policy helped create this exact scenario. This diagram illustrates the export control paradox. By building gates to block Chinese labs from accessing advanced microchips, the U.S. forced competitors into the lower lane. To survive, they optimized for hyper-efficient training and aggressive open-weight releases, spreading their technology globally despite hardware limits. The result is the map we see here. The glowing nodes in North America represent isolated premium APIs, while the web expanding across the globe represents low-cost open models running on developer laptops and local servers worldwide. The strategic question is not who builds the smartest model in a closed lab. It is whose model becomes the default standard for the entire planet. There is a physical limit to this open expansion. Hosting a 744 billion parameter system requires immense on-premise computing power. An enterprise needs massive server racks and industrial cooling systems to run these models locally. True independence still carries heavy infrastructure costs. GLM 5.2 does not end American tech dominance. Top-tier U.S. labs still maintain major advantages in distribution, compute power, and enterprise trust. What this model proves is that frontier-level intelligence is rapidly becoming abundant. An industry priced for absolute scarcity now faces the reality of global commoditization.